In this session, I will be going over graphing a rational function, and this particular one, we will talk about finding asymptotes. So it's a lengthy process to graph rational function, and I realized that I cannot do it in one session, so I'll be breaking down into the sessions, and this one will find the asymptotes. So there's a vertical, horizontal, and oblique possible asymptotes, and we'll start with a vertical asymptote. So to find the vertical asymptote, all you need to do is to take denominator of rational function and equals it to a 0. Solve it for x equals 3. So the line x equals 3 will be your vertical asymptote. So you need to locate x equals 3 on coordinate system 1, 2, 3 and draw a vertical line. So this is your vertical asymptote, x equals 3. Now horizontal asymptote is a little bit more trickier. So to find the horizontal asymptote, what you need to do, you need to compare the degrees of numerator and denominator. So the numerator, we have x plus 1, and denominator is x minus 3. So the degree of a numerator, I will call it an n, equals 1. And because it's the highest power, so it's 1, and degree of denominator, I'll call it m, so it's the highest power of a variable of the denominator, equals 1 as well. So because n equals m, because the degree of numerator and denominator are exactly the same, to find horizontal asymptote, what you'll need to do, you'll need to take the leading coefficient of numerator and divide by the leading coefficient of denominator. So that the leading coefficient of numerator is 1, it's 1x, and the leading coefficient of denominator is 1 as well, so it's 1x, will be 1 over 1 equals 1. So y equals 1 will be your horizontal asymptote. So y equals 1 is here, and I'm gonna draw the line that will be your horizontal asymptote. In this section, we'll be continuing working on graphing a rational function, and so far we were able to locate the vertical asymptote and horizontal asymptote, and in this segment we'll concentrate on finding intercepts. So there's an x-intercept and a y-intercept. First we'll start with x-intercept. So recall what x-intercept is. So the x-intercept is a point where your graph will be crossing x-axis. So for that point, you will have some coordinate of x, but the y-coordinate will be always 0. So we'll use the fact that y equals 0, and we'll substitute, instead of y, we'll use 0, and we'll find x. So x plus 1 over x minus 3 equals 0. To solve this equation for 0, you have a fraction. So the fraction equals 0 only if numerator equals to 0, because remember, denominator cannot be 0, meaning if the fraction equals 0, then numerator has to be 0. So the numerator is x plus 1 equals 0, so x equals -1. So the x-intercept point will be -1, 0, which is right here. And the y-intercept, so let's find y-intercept. The y-intercept is the point where your graph crosses y-axis. So at the point of crossing, you will have some coordinate for y, but the x always be 0. So what I'm going to do, I will substitute 0 into the function and find y. So 0 plus 1 over 0 minus 3 equals -1/3. So the y-intercept is 0, -1/3. So the point is somewhere right here. So that will be your y-intercept. In this session, we'll be continuing towards graphing rational function, and we will be using the sign analysis to figure out the graph behavior around a vertical asymptote. And one of the ways to do it, there's a technique how to do it, and then one of the ways I'll teach you how to use critical numbers. So first, we will need to find so-called critical numbers. And that's the numbers that turn numerator and denominator into 0. So the numerator is x plus 1 equals to 0, and then denominator x minus 3 equals to 0. So the first equation, I need to solve for x, and it will be -1. And then the second one, x equals 3. So those two numbers, we'll call them critical numbers. So how you can use them? You will need a number line, and you will locate those numbers on a number line, so -1 and 3. So that those two numbers will break your number line into intervals. So the first interval will be from -∞ to -1, the second interval from -1 to 3, and then interval from 3 to infinity. So what you'll need to find out on those intervals, your function will have a positive or negative sign. So if your function will have a positive sign, then the graph will go above x-axis. If your function will have a negative sign, then the graph will go below x-axis. So to figure out the sign, I will use a test points for each interval. Test points. So for the first interval, I will use, let's say, -2. So x equals -2. What I will do, I'll plug it in instead of x and see what the sign will function have. So g of -2 equals -2 plus 1 over -2 minus 3. So will be -1 over -5, which is 1/5, which is positive, so the sign is plus. And this interval will be plus. Then second interval from -1 to 3, I'll use test point 0. So g of 0 equals, and I'll plug in 0 instead of x, will be 0 plus 1 over 0 minus 3 equals -1/3. So that on this interval will be minus, meaning that your function will go below x-axis. And then the third interval, I will use number 4 as a test point. So g of 4 equals, and I'll plug it in, 4 instead of x will be 4 plus 1 over 4 minus 3 equals 5 over 1, which is positive, so it's a plus. So on the first interval from -∞ to -1, your graph will be above x-axis. Then between -1 and 3, it's gonna go below x-axis, and then from 3 to infinity, it's gonna be above x-axis. So now we can finally graph that rational function. We've been working for a few sessions now. And so far, let's recall what we did. We figured out vertical asymptote, x equals 3, horizontal asymptote, y equals 1. We figured out x-intercept -1, 0, and then y-intercept will be 0 minus 1/3. Then we also find out that we find out how the graph behaves around vertical asymptote. We figure out that on the interval of from -infinity to -1 gonna be above x-axis. Then the interval between -1 and 3 gonna be below x-axis. And then interval from 3 to infinity going to be above x-axis again. So all we need to do is just to use few extra points and graph the function. And I chose a point from each interval. So if x equals -2, y will be, so I need to plug in -2 into the function. So that will be -1 over -5 will be 1/5. So point -2, 1/5. So it's going to be -2, 1/5 somewhere here. Then if x equals 1, and again, points are random, and I like to have as many points I can to be precise. You don't have to have all of those points, but we're just going to go over them quick. So if x equals 1, then y will be 1 plus 1 over 1 minus 3. So will be 2 over -3 will be negative, 2 over -2 will be -1. So 1 minus 1. So it's going to be right here. And you can kind of see that curve when it goes from, so it goes above x-axis and then crossing where the x-intercept is, then crossing where is the y-intercept is, and then that's the point which is figured out. So it's going to be that nice curve, and then going down from the point still, because remember on the interval -1 and to 3, it's still above x-axis. So next point, x equals 2. So y will be 2 plus 1 over 2 minus 3 will be 3 over -1, which is -3. So point 2 minus 3. 1, 2, 3 is right here. So getting into this point, and then goes down, and just remember it never crosses vertical asymptote, so you can leave it right there. Now if x equals 4, so that's the interval from 3 to infinity. Remember an interval from 3 to infinity is going to go above x-axis. So if x equals 4, then y will be 4 plus 1 over 4 minus 3, so will be 5 over 1, so will be 5. So if it's 4, then it's going to be 1, 2, 3, 4, 5. It's going to be somewhere here. And then I was thinking of 7, but I cannot fit 7. If x equals 7, I'm just going to calculate 7 plus 1 over 7 minus 3 will be 8 over 4, which is 2. So if it's 7, it's going to be 2, meaning the curve going to be nice and high, and it goes all the way that way. So that's the function, and it's completed.